So for the sake of time, I'm going to introduce Xander Ernst. He's our next speaker. And with introducing Xander, I can't but say a few words about his father, Andre, who was, when we talk about genetics, Xander definitely comes from good genetic material because many of you know of Andre. He is responsible for microcloning of avocados with removing the clonal from the nurse seed. He is the mover and shaker behind the Maluma the Maluma avocado, which is can be grown perhaps as a complement or an alternative to Hass. And Andre was just a very driven individual. And so I met Xander several years ago when I was visiting South Africa and was immediately impressed by Xander's dedication to all things avocados. And one of the things that Xander has sort of been the leader on is adapting trellising to avocados. And that's what we've asked Xander to talk about today. So Xander.
Thanks, Mary Lou. Thanks for the introduction. Sorry, I just need to get my screen shared. And happy to go. Sorry. Okay. Assuming everyone can see my screen now. Yeah, thanks firstly for the opportunity. Very controversial, I'm sure. And yeah, if there's anyone tonight that believes it's still impossible, you won't be the first to think so. But hopefully I can change a few minds, and yeah, I think, feel free to contact us. But I'm going to run through a lot. It's a lot of information. It's at least about 6 to 8 years worth of testing and trialing to get to something that I can present to you today, and something that makes me extremely optimistic. Okay, I'm stuck on a slide, yeah? Okay, let me just see if I can get it going. Okay, good. Yeah, so one of the keys to higher production is improved pruning practices. And I think, to adjust and understand the bearing pattern of the tree. In avocados, we tend to have fruit producing on the outside of each shoot, and this presents a challenge. So at the end of the day, we believe trellising simplifies tree structure and makes it easier to identify which branches are productive and which aren't, and to physically understand the process within the tree a lot easier. In most other fruit crops, trellising has shown to improve production, be way beyond previous measurements. In avocados, we believe the move from 200 to 400 trees per hectare was a massive change. But it was met with a lot of issues where alternate bearing started coming in, and it presented pruning challenges. A lot of growers went to thinning the trees, every, let's say after 7 years, taking out alternate trees. And this is not a sustainable pruning practice, and ended up even in South Africa with a lot of growers going back to wider spacings. South Africa has a warm climate, as some of you might know, very good and deep soils, which allows for a lot of growth vigor, in particularly with cultivars such as Hass. So it presents a big challenge in terms of managing that growth and managing alternate bearing. In terms of trellising, growth vigor is our biggest challenge. And the major assumption is that avocados can't be put through rigorous pruning because the way it reacts to pruning is, extremely vigorous growth. So in terms of high density, we need to have limbs to produce fruit. But high density, however, makes it very possible, like I said earlier, to actually manage a tree on a micro level and look at specific shoots instead of sections of the tree, if you want to call it that. However, in the photo that you see here, I think at this point the trees were about 2.5 years old, and you're still struggling to fill the gap, because with new generation cultivars comes new challenges. They tend to produce a lot higher, a lot earlier, and this has its challenges that I will come to. In terms of conventional avocado orchards, I hope none of you knows this person on the photo. I just quickly got this off Google today. But in contrast with high density plantings, wider densities present challenges like these photos. Perfect picnic spots, but the worst place to produce fruit. All the fruits in the top of the canopy. And once you start looking at harvesting efficiency, this comes second to high density production. So now you have to look at, growers saying, yes, but this gives me better production. But when you look at spraying programs, pruning programs, as well as harvesting, this does present efficiency challenges. So what are the objectives of micromanagement? We want to increase production beyond norms that we currently know. Accuracy of tree management. Again, you can focus on specific shoots and not sections of the tree. Whereas a lot of people might use methods of pruning such as major limb removal, now it's possible to focus on a specific shoot. Preventing and managing alternate bearing. So by understanding the tree better, as in the initial quote, we have the ability to target pruning in a specific route. And we believe by targeting these first three actions, you now have the ability to harness the full potential of a tree with that branch selection. Why should we look at trellising? Micromanagement motivation, as I've mentioned. We, as Alles Beste, believe that we need to push the boundaries of production. It's not sustainable to maintain production where it is today at the current norms that we know. I would say a huge, let's call it 50% of avocado production in the world, in our opinion, is in microclimates and climates that allow growth vigor, that don't have limiting soils or limiting microclimates. And this gives us low production. And those areas won't be sustainable in the coming years, competing with the major industries. We need to improve yield per hectare. New productive cultivars like Maluma, new generation cultivars that are highly precocious, present their challenges in terms of branches bending, past the 90-degree angle. Now, those of you that might know, is in industries like the apple and pear industry, deciduous fruit, they did a lot of research on what the angle is where optimal production exists. So in apples, they tend to bend down the branches. We need to pick up the branches, as that a lot of research has shown that production goes backwards when the attachment angle to the vertical branch goes past 90 degrees. It creates an overshadowing of the tree, and we try and prevent that. So it's a opposite of what they do in the apple industry. We increase efficiency of production, as I've mentioned, spraying, harvesting, and pruning costs. Improving the return on investments or your capital, improvement on cubic production capacity or efficient yield. So as I've mentioned, bringing the production lower, so not having the perfect picnic spot, but all the fruit 4 or 5 meters above the ground, but bringing everything down to a manageable height, let's say between 1 and 3 meters. Speed up the time to full crop potential or full production. So we don't want to wait, let's say 4 to 7 years to reach full production. We want that as soon as possible. And again, manage alternate bearing. So when I mentioned, precocious trees, this is a Maluma tree that's 10 months old and branches already bending downwards. So immediately this affects, the growth potential of the tree and, what the growth will look like after a year. But by managing these branches, managing these shoots, you have the ability to manage the tree going forward. So what is different on trellising avocados versus other fruit types? The precocious cultivars need support systems. So it's not about solaxing, it's about actually picking up branches. We don't have dwarfing rootstocks, but I personally believe we don't necessarily need dwarfing rootstocks. The apple industry had the perfect cultivars, but they didn't. So they had to find the perfect rootstock to inhibit growth. With us, I think there is huge potential to improve on cultivars. So we can select cultivars that are more precocious and semi-dwarfing or dwarfing. So it's all about the motivation behind the breeding and selection programs. Avocados are evergreen, a lot of energy to manage. We have soft wood, so we need to manage sunburn and light penetration. We need 4 to 6 month old wood to produce flower. A lot of literature says, you know, a year to a year and a half old material to produce fruit. So we believe with the new generation varieties, this is shorter, but it's still something that you need to plan ahead for. And then the cropping habit and patterns of the trees is a bit different. We tend to bear on the outside of the tree, and the natural synleptic angle comes back to branches bending downwards. So where are we today in terms of trellising in South Africa at Alles Beste? Started in 2015. Today we sit on 21 hectares of production on a commercial level, and still expanding this beyond that 21 hectares. So at the moment, it's a rough split, roughly 50-50 of the vertical and the Tatura trellis that Mary Lou referred to. So this was our first trials. Our first commercial trial. Before this, we did a very, very small trial just to see whether it could work. And you can see the trees were already approximately a year and a half old here, because we wanted to see the results as quickly as possible. So you can imagine with that, we've had to prune the trees quite hard, you know, to get them on the wires. And we basically assumed we would lose a crop and need to skip it. The reaction of the trees was what surprised us, and we saw a lot better flower than we, you know, expected. In terms of the ideal size to start training, however, I would say up until 1 meter. That gives you the ability with a lot of flexible branches to get more lateral shoots onto the wires. This was some of the reaction we saw on the first year after training on the trellis. You can see a lot of flower development straight from the vertical. So this is something that you do sometimes see in restrictive environments like Chile and Peru, but it's not something that we used to in South Africa, to see flower developing straight, you know, from buds like that. Some statistics. So you'll see we did a trial with different wire spacings, 150 millimeters apart, 200 millimeters apart, and 300 millimeters apart. So that would be wire spacing running up on the vertical to support the lateral branches. So initially the 200 mil looked quite good, but the top performer was the 300 millimeters. The same pattern developed in the second year of production, still 300 being the leader, but Tatura looking quite well. And then in year 3, still the 300 doing quite well, but single tree Tatura and double tree Tatura falling backwards a bit. But these trees were about 12 months younger than the other trees. So it was a bit of a catch up and playing, but we were quite in a rush to see some results. Sorry, I just want to double check that I'm not missing something there. Yeah. Okay, then, so yeah, sorry if I just go back to this. So in our opinion, you know, the 300 was looking quite good. What I can also mention about this initial trial was our main purpose was to do minimal interference. So literally just train the tree and see what happens. So there was a bit of reactive growth vigor and things that we couldn't manage, and we were still learning. And at that point, that trial was about 1.9 hectares amongst about 280 hectares of avocado. So it wasn't, you know, diligently managed, you know, on the spot. And we started saying, okay, perhaps we should try growth regulators. We didn't see significant differences in applying the growth regulators. At this point, we did foliar sprays with it. on about 2 liters per hectare, following it up within 2 weeks. So that was the protocol that we followed. Currently, in terms of the commercial blocks, this is the type of production that we are looking at. And I would say the major lesson that we've learned was to focus on these blocks. And one of the reasons why we decided to expand exponentially to the commercial point was that the more blocks you have, we were saying we need at least 10% of our production on trellis to afford the attention to manage it effectively and on time. So pruning on time and all of that. So what we see at the moment is the orange line at the bottom. That is conventional hash production in South Africa. So usually 4 years after planting, you reach crop maturity, and from there on, alternate bearing starts. So it starts very slow. Usually from year 7 onwards, this becomes, let's say a 5 to 8 ton gap between on and off year. In terms of industry averages, just to put it in perspective, South Africa's industry average, all cultivars included, is around 9.5 tons to the hectare. So this is good production. It's in South African terms, this is really good production. But now when you look at trellising, in year 1, there's already a huge gap between the vertical and the Datura trellises. This is physically 12 months after planting. So it's exact 12 months after the date of putting the tree in the soil that crop was taken off. Then this is the current crop that we project on the trees. We've done this with a fruit count. And basically this gives us then, sorry, I see the dates at the bottom is a bit odd. So yeah, basically this is done on a fruit count and average fruit weight calculation, and it's currently gives us a projection of 28 tons on the top performing Datura trellis. So we know this is possible. But even if you go down to the averages, there's a massive gap of, let's call it 11 to 15 tons to the hectare. And this is what really excites me. So when you look at cumulative production, again, conventional hash on the right, and you can see Datura vertical all outperforms the conventional hash. So the red line being after 2 production seasons. And again, the trellising being beyond that. Then if we compare Maluma to Maluma, so untrellised Maluma versus trellised, again, you can see 18% improvement on vertical trellis to untrellised Maluma. And the moment we go to Datura trellis, then we look at 77 to 100% improvement in production. So even if we are met with challenges, we've significantly moved the return on investment forward. Sorry, I just want to check my time here. Yeah. So in terms of, again, managing or looking at statistics, I would say the most important thing here is to look at standard deviations. So PC1 on the right, that's the conventional orchard, Maluma, it's not hash, so Maluma compared to Maluma. And you can see the amount of deviation that we sit with in conventional orchards, whereas the Datura and the vertical is a lot closer to each other. So when you look at this PB1A, this is the physical fruit counts that they've done, and the amount of fruits on the trees you will see is quite close to each other and very few noughts. However, the moment you go to conventional orchards on this paper, you will find a lot of variance. 1, 3, you'll see zeros not far from each other, 4 and a 2. So that deviation in terms of fruit per tree or kilogram per tree is what brings our production down. So definitely exciting to see stability within an orchard and achieving those goals. So what we also did was look at the Datura production on a single tree being split, into 2 shoots going up, or planting double the amount of trees. So 1,200 trees to the hectare or 2,500 trees to hectare. And we were quite surprised to see that the single trees actually outperformed the double trees year on year and also with this year. So it's not a chance, it actually repeated itself. Then in terms of harvesting window, does it make a difference? So at the moment, so last year, this is last year's actual dry matter analysis. And you can see there, the trellis was harvest ready by, 9th February, whereas conventional orchards were only harvest ready between 23 and 30 March. For interest's sake, we started doing our dry matter analysis last week, not last week, the last 3 weeks. And the same is repeating itself this year. So it seems like it is roughly a month to a month and a half earlier than the conventional orchards. In terms of quality and fruit size spread, so the top graphs being for conventional Maluma orchards, this is our 10-year average over all the blocks. So 66%, grade 1, peaking on account 14. So remember, as Alasbesta, we've been planting a lot of young orchards. So that 14 on the older orchards, we see a higher percentage of 16, 18, 20. So just keep that in mind. But if you look at the trellising, you'll see what actually happens with the graph is it pulls it very narrow. So now currently peaking on account 14. My expectation is that it keeps this narrow graph, but it will move to account 16, 18. It tends to move down about 1 to 2 sizes. In terms of management aspects, we decided last year to investigate a lot in terms of uniconazole applications. The main reason for this is, remember, our microclimate is very growth vigorous to try and see how we can manipulate the trees. And the main idea for me behind this is twofold. The one is, if you look at the deciduous fruit, they hibernate during the winter months when they drop their leaves. And I wanted to simulate that and see what the effect on flower and production could be. The other side of the coin is in terms of longevity of the tree and reaching production past year 4 and working towards the 40, 50, 60 tons a hectare. We wanted to see what can we achieve with uniconazole. In terms of pruning, we were looking at twice a year annually. So it's a pretty quick and fast pruning. It's not major cuts, which I will show. Water bullshit removal, refractive paint is crucial in terms of the branches or the main stem specifically. And my personal opinion is uniconazole is not needed in climates where there's less growth vigor. So let's say more restrictive soils or more restrictive climate. Then in terms of pros and cons, vertical trellis is very easy to set up, very easy to manage, cheaper to construct, and it has a shade net suitability, but there is a low surface utilization. The Tura, on the other hand, more costly to set up, but there's a huge spatial utilization or spatial optimization. In terms of improved spacing, I'm going to step onto the photos. We need to close these gaps in the trees a lot faster. These trees at the moment that you're looking at was at the 3-year mark, and we want to reach full maturity as quickly as possible. So by playing with tree density, we should be able to close those gaps a little bit faster and, even pull production a lot earlier. So my current opinion would be not to bring the density closer within the line, between the lines, but rather increase density within the row. So let's say maybe to 1 meter or 1.25. What I believe we've done wrong in the past is we were obsessed about thinly trained trees. So we had these very slim cut trees. So we are looking at, diversifying the tree a little bit into the row with more lateral branching, not just on the wire. Tree height has been something that we've been looking at. By increasing tree height, you can gain about between a ton and a ton and a half per hectare for every wire on 300 millimeters that you go up. So with our tree height going up now to 3 meters, we can gain about 4 tons a hectare. But that is what you're already seeing on the commercial blocks. Labor training and retention was quite crucial. Since we've done that, we've improved quite a lot, and the accuracy, like I've mentioned, timing the tasks. We need to still play a little bit with Datura angles. I think we can move a little bit more to the upright. The Datura system itself is not very sturdy because of the angles of the poles, whereas on the vertical, the poles and the structure of the tree itself actually keeps the fruit up quite well. So it doesn't put a lot of pressure on the wires. But unfortunately, on the Datura, the weight is on the diagonal. We still need to look at density and bigger wire spacing. Currently, I would say optimal tree height would be 3 meters. There I've mentioned the 4.5 tons a hectare. Density could possibly be increased, but then with current tree costs, you have to be careful not to push the return on investment back. This is just a tick box, just to show you what we have achieved or what we've ticked off in terms of improvements with trellising, spatial utilization, increased flowering, increased fruit set, higher yields, better quality fruit size improvements, wire spacing, inter-row spacing, return on investment. Wind protection, I think, is a major objective that we should achieve. We haven't trialed it yet, but we are in the process of testing that now. But I think it could be a major benefit of trellising. Just going to run you through some photos. You can see the flower that I mentioned developing straight from the trunk. Fruit set, you can see the percentage of fruit set, very good. And we personally believe, this flower moving back into the shoot or onto the lateral branch is a result of better light penetration. So more light going into the tree. So those of you that know, is the norm on avocado tree research shows is that production sits between 1 meter and 1.5 meters into the canopy of the tree. The moment you go deeper than that, production is lost because sunlight penetration is not optimal. So a lot of what we focus on the trellis is to keep the thickness of the tree. So let's say the lateral movement of the tree between 500 millimeters and 1 meter. That's where we believe the optimal production area sits. So just a few photos of yield on the tree. What you'll notice is the lateral movement of the fruit. So the fruit being along the wire the whole time. So when we start looking at mechanical harvesting, let's say 5 to 10 years down the line, this becomes a very easy task because all the fruit's hanging on the same height and it's between the two wires. We also have more and more fruit hanging in clusters. My personal opinion is this is due to better pollination. You can imagine, with better sunlight penetration, again, bees might be pollinating a bit more efficiently with flowers sitting in full sun. Again, fruit in clusters. Production sustainability. So a lot of people will say, yeah, but you'll have 2 or 3 great crops and then you sit back. So when you look at these little spurs that develop all the way back on the lateral, that's where we believe the sustainability of production sits. So managing the tree on the micro level to produce more of these spurs. And again, those spurs are a resultant of sunlight penetration. Again, you can see the size more or less of the spur and the bud starting to develop there. So have good differentiation within the tree. Selective pruning is quite simple and easy. Back to the selective growth. You can see in this scenario, what we would do is just cut that shoot there. We don't want downward growth into the tree that blocks sunlight from getting onto the next lateral. So, if you're unhappy with growth like that, it's a simple cut. So because these cuts are very thin and on very soft shoots, you can imagine the speed with what we can do that. This rejuvenated shoot developing there, being bound on the wire like this, and you would remove these older branches, rejuvenating the tree again. So flower bud development, look how it develops back on the lateral. Again, you can see the flower buds developing. Again, the rejuvenation of the spurs. This is the current production on the trees. I think it's quite visible, very consistent between the trees. And, to sit on, let's be pessimistic and say we don't reach the 28 tons, but we reach 18 to 20 tons hectare. You can see we haven't filled the full potential of the orchard yet. Again, major gaps between the trees. Again, consistency between the lines and the trees. Datura showing some production and how well it's maintained on the inside. And this is done with really, 2 prunings, of which one is a hard pruning after harvest. And the other pruning is done a soft pruning while the fruit's on the tree in the summer months. So again, consistency. Again, you can see the habit of the fruit being, between the wires. So if you look at mechanical harvesting, what you want to do is have something running across just below the wire, cutting that and dropping it into a chute. So challenge at the moment is with high crops, you have more bare branches like this. So we were quite stressed about that. But what you'll see here is after starting our fertilizer program, we've seen more and more, little spurs like that again developing, little rejuvenation shoots. So it might be coming back to that, cutting it there and rebinding that. So it all depends, we're still in the learning curve. More concerns is obviously with higher yields. How do we balance, macro and micronutrients for that matter? So this is still a learning curve. Currently, I can tell you we're running with nitrogens as high as 3, where the norm used to be for Maluma between 2.2 and 2.4, and with no effects on quality or post-harvest quality. Structural integrity of the Datura, balancing growth vigor, as I've mentioned. And, how do we ensure consistent rejuvenation? So again, with too much uniconazole, what we've seen is we have inhibited the rejuvenation of the tree. So we should not necessarily look at uniconazole as a solution. Again, production, what's really exciting is being on 20 plus tons with our, within 36 months of production. I think rootstock is crucial to this. The more precocious rootstock, the better production we see. So currently DUSA are setting the pace. I can also mention we have started 32 rootstock trial on Maluma on trellis to find the perfect rootstock for trellising. And the first results will be on the trees, will be harvested this year. In conclusion, trellising on new generation precocious cultivars like Maluma is definitely successful. So if I have to include other cultivars, I would say Pinkerton, Lamash. I don't have experience with Gem, but I do believe Gem has the same potential. Even in warm climates, semi-dwarfing cultivars can be trellised. So I think the potential in more restrictive climates are even higher. Enables micromanagement and production planning. We have optimal light penetration, in my opinion. Datura is expected, and I honestly believe that it is the preferential system. But for someone with a less intensive management, I think vertical systems are still way superior to conventional pruning. Increased production is not yet equal to increase in flowering, so I do believe there's still, ample room for improvement. Vegetative regrowth, I do believe, is under control. It's not a threat, but I think it's finding a perfect balance between rejuvenation and managing growth vigor. Production is significantly improved. Then a last slide. This is a timeline of what the major changes in the apple industry was. And when you look at this, in the 1950s, they went to the densities that we are currently farming at, unless you're in Chile and planting, 3 by 3. This leap was only taken in the avocado industry, let's say in the 1990s in most of the industries. These light inception studies, optimal angles are things that we are looking at now. Reaching 1,200 trees, yes, there are some industries doing that. As Alesbesta, we have about 50 hectares already above 1,000 trees per hectare. But when you look at tonnages, we are still mostly in this bracket. Some of us are reaching that bracket. But when you look at this timeline, my personal opinion is that we are probably 40 years behind, the curve. And what I'm saying to you is that, yes, a lot of you will say, we haven't proven this yet. We haven't figured out the exact pruning yet. We haven't figured out the exact nutrition program. But I think you have to bear in mind the boundary we're trying to shift here. We're trying to shift in a 10-year period. We're 6-7 years down the line. And I think we're making massive progress. I think we've made leaps in terms of this timeline so far. So I just want to thank you again for the opportunity. Thank you for bearing with me. I know I've been trying to convey a lot of information in a short time, but I hope you kept up. So yeah, thank you very much. Questions, welcome.